Yeah, hello, good evening, everyone. Welcome to interview preparation session on 22nd of 1st 2022 by 360 DGTMG. Um, we'll wait for a few minutes and we'll just start the session. Okay, we'll just let others to join the session. Yeah, let's wait for 2 more minutes and let's start the session, guys. Yeah, okay, guys. Good evening to one and all, and welcome to interview preparation session by 360 degree DGTMG. Uh, as a revision of previous classes, we have been seen the interview preparations on Python and its basics. Not only on basics, we also went through some of the deeply topics of this Python. And yesterday we have seen some of the questions on data science, and today also we'll see some of them which might helpful to you. Okay, yeah. As jumping into the first one, what are the differences between the supervised and unsupervised learning? Okay, if anyone knows the answer, please ping in the chat box. I'll be seeing your replies. We'll discuss the answer in a minute. Okay. Yeah. As comparing both the supervised and unsupervised learning, there are many differences. Among them, most of the important differences are these supervised learning are users are known and labeled data as inputs, whereas the unsupervised learnings are users and unlabeled data as an input. Okay, supervised learning has an feedback mechanism, whereas unsupervised learning doesn't have any feedback mechanism. The most commonly used supervised learning algorithms are, which we come across in this supervised learnings are decision tree, logistic regressions, and support vector machines. Okay, whereas as coming to the unsupervised learning, we'll come across k-means clustering, hierarchical clustering, and appropriate algorithm. These are the main differences between them and how we use both of them separately. Okay, yeah. As jumping into the next one, how is logistic regression done? How the process is done? If anyone knows the answer, ping in the chat box. I'll see your replies. I would like to give you a minute. If anyone will discuss the answer in a minute, okay? Yeah. Now, as looking into this logistic regression, it basically measures the relationship between the dependent variables and one of the more independent variables. Which dependent variables means our label or of what we want to predict, and our independent variables are our features. Okay, what we are able to get the data by estimating probability using its underlying logistic functions. Okay, this is how the logistic regression is done. As jumping to the next one, explain the steps in making a decision tree. Okay, how this decision tree process goes on. What are the steps to be followed? If anyone knows the answer, ping me in the chat box. I'm seeing your replies. We'll discuss the answer in a minute. Okay. Yep. As looking into this, these are the steps to be followed to make a decision tree. Okay, I'll explain you somewhat deeply. Okay, first we have to take the entire data set as input. Okay, what are the required amount of data sets, what are the required data, we have to take the entire data set as an input. And now the first step is that we have to take the entire data. As coming to the next one, we have to calculate the entropy of the target variable as well as the predicted attributes. For the entire data set, we have to calculate the entropy as well as the predicted attributes which we have been predicted. Okay. As coming to the next step, we have to calculate your information gain of all attributes. You have to calculate the information gain of all the attributes which have been given in the data sets. Okay. And the next step is we have to choose the attribute with the highest information gain as a root node. This is the fourth step we are doing in the decision tree. As coming to the final step, we have to repeat the same procedure on every branch until the decision node of each branch is finalized. Okay, these are the steps to be followed to in the making of a decision tree. Firstly, we have to take an entire data set, and the second step is we have to calculate the entropy as well as the predicted attributes. And third step, we have to calculate the information gain of all the attributes. And the fourth step is we have to choose some attributes which are of highest information gain as compared to the root node. And the fifth step is we have to repeat this procedure for every branch until the decision node of each branch is finalized. Okay. Yeah. Now, as jumping into the next one, how do you build a random forest model? Means, what is the process of building this random forest? If anyone knows the answer, please ping in the chat box. I will be giving you a minute. We'll discuss the answer in a minute. Okay. Yeah. Now, as looking into this, how do you build a random forest model? Okay. Yeah. Basically, the random forest is built up of a number of decision trees. Okay. If you split the data into different packages and make a decision tree, in each of the different groups of data, the random forest brings all those trees together. Okay. Steps to build a random forest model. These are the steps to be followed to build a random forest. The first step is randomly select k features from a total of m features where k is much lesser than m. Okay. And the next step is among the k features, calculate the node D using the best split point. And the third point is split the node into daughter nodes using the best split. Repeat steps 2 or 3 until leaf nodes are finalized. Build forest by repeating steps 1 to 4 for n times and create n number of trees. By this, we'll find out to create the how to create the random forest. Yeah. As jumping into the next one, how can you avoid overfitting for models? What are the steps to be taken to overcome this overfitting model? Yeah, I'll be giving you a minute. We'll discuss the answer in a minute. Okay. Yeah. Now, as coming to this, how can you avoid overfitting your model? Okay. Overfitting, it basically refers to a model which is only set for very small amount of data, which means we take it, this overfitting only takes for very little amount of data sets and ignores the bigger pictures, okay, bigger data. And three main methods to avoid overfittings are keeping the model simple, which means we have to keep the data as simple as it is, okay. It takes fewer variables into accounts, thereby removing some of the noise in the training data. As coming to the next step, use cross validation technique such as k-folds cross validation. This is the second step. As coming to the third one, use regularization techniques such as lasso technique, the peninsulize certain model parameters if they're likely to cause overfitting. By using these three steps, we'll uh, we comes under the avoid overfitting models, okay. Yeah, as coming to the next one, suppose you are given a data set which consists of variables with more than 30% missing values, which means NA values. Okay. How would you deal with them? As you see, as I, for example, I've given you a data set where 30% of data set is empty and most of the columns were of null values. So how do you deal with the data set? So if anyone knows the answer, ping me in the chat box. I would like to see those answers and we'll discuss the answer in a minute. Okay. Yeah. Now, as coming to this, the following are ways to handle missing data values. Okay. If the data set is very large, we can just simply remove the rows with missing data values. It is the quickest way. We use the rest of the data and predict the values. Okay. For a smaller data sets, we can substitute the missing values with the mean or average of the rest of the data using pandas data frame in Python. There are different ways to do such as df.mean, df.fill, and these are the functions or to do if we how to handle the missing of data. If there we have two different steps. If we want to handle the uh, data set of very large data, we have to remove the missing rows and columns which have null values. And if we want to do the process with a very small data sets, then we have to come across by doing this mean variance and all these methods to overcome this null values or plain values. Okay, yeah. As jumping into the next one, what are dimensionality reduction and its benefits? If anyone knows the answer, please ping in the chat box. I'm seeing your replies. I will discuss the answer in a minute. Okay. Yeah. Now I was looking into this. The dimension reduction, it basically refers to the process of converting an data set with vast dimensions into data with fewer dimensions, okay, to convey similar information concisely, which means very huge amount of rows and columns with a required amount of rows and columns. This reduction helps in compressing the data and reduces the storage space. Okay, by using this dimension reduction techniques, it basically compresses the data, by which we can save a huge amount of reduce the storage spaces. Okay, it also reduces the computation times as fewer dimensions leads to less computing, and it also removes the redundant features. For example, if there is no point in storing a value in two different units, okay, meters and inches, okay, like take this and assemble. uh, yeah, Vivek, you are right. In the chat box I've been seeing. Now, as jumping into the next one, how can you select k for k means? Okay, if anyone knows the answer, please ping in the chat box. I'll be seeing your answers. We'll discuss the answer in a minute. Okay. Yeah. Now, as looking into it, how can you select k for k means? Yeah. Now we use the elbow method to select K for k-means. What is elbow? Which it actually means, this is an idea of an elbow method is to run k-means clustering on the data set where k is number of clusters. Okay, within the sum of squares. Okay, WSS within sum of squares. It is defined as a sum of the square distance between each member of the clustering and its centroid. Yeah, Vivek, you are right in the chat box. Now we are as looking to the next one. How can outlier values be treated? Uh, I think you have an idea on outliers. So how the outliers values we will treat them as. I'll be giving you a minute. If anyone knows the answer, please ping in the chat box. We'll discuss the answer in a minute. Okay. Yeah. Now as we looking into this, how can outliers values can be treated? Yeah, you can drop outliers only if it is a garbage value. Okay, if the value is not useful for you for your required data, you can drop it as a garbage value. For example, height of an adult a b c will measure the height in feet, right? This cannot be taken as the height cannot be a string value. In this case, outlier can be removed. If the outlier has extreme values, they can be removed. For example, if all the data points are clusters between 0 to 100 0 to 10, sorry, but one point lies at 100, then we can remove this point. If you cannot drop out layers, you can try the following. These are the steps to be followed if you cannot drop the outliers. Try a different model. Data detected as outlier by linear models can be fit by non-linear models. Okay, therefore be sure you are choosing the correct model among the one. Okay, as coming to the next step, try normalizing the data. If you cannot drop the outliers, you have to try the normalization function in the Python. Okay, this way the extreme data points are pulled to a similar range. You can use algorithms that are less affected by outliers. An example would be random forest. Okay, uh, yeah, Pandya and Vivek, we can use for removing, trimming as well as this winterization techniques. Okay, yeah. As jumping into the next one, what are the feature vectors? What are they? I'll be giving you a minute. If anyone knows the answer, please ping in the chat box. We'll discuss the answer in a minute. Okay. Yeah. Now, as we're looking into is what are the feature vectors? Okay. A feature vector is an n-dimensional vector of numerical features that represents an object. Okay. This basically feature vectors represents the object. In machine learning, feature vectors are used to represent either the numeric or the symbolic characteristics. Okay, of an object in a mathematical way that's easy to analyze. Yeah, as jumping to the next one, what is root cause analysis? If anyone knows the answer, please ping in the chat box. I would be giving you a minute. We'll discuss the answer in a minute. Yeah. Now, as we're looking into this, what is root cause analysis? Root cause analysis was initially developed to analyze the industrial accidents, but is now widely used in other areas. It is a problem solving technique used to isolating the root causes of fault or problem, or like what is the exact fault, what are the problems facing by it. A factor is called as root cause. If it's a deduction from the problem fault sequences, it averts the final undesirable event from recurring. This is how the root cause analysis work. Yeah, as jumping into the next one, what is logistic regression? I think you all might know this answer. If anyone knows the answer, please ping in the chat box. I will be giving you a minute. We'll discuss the answer in a minute. Okay. Yeah. Now, as looking at this logistic regression, this logistic regression is also known as logic model. This is a technique used to forecast and binary outcomes for a linear combination of predictor variables. Okay. Yeah. Now, seeing the next one, what are recommender systems? If anyone knows the answer, please ping in the chat box. I will be seeing your replies. We'll discuss the answer in a minute. Okay. Yeah. Now, as we're looking into it, recommender systems are a subclass of information filtering systems that are meant to predict the preferences or rating that our user would give to a product. Okay. These are basically requires for preferences to predict of preferences or rating of that would be required to give to a product. Okay. What is collaborative filtering? Yeah, we'll discuss this answer in a minute. If anyone knows the answer, please ping me in the chat box. Yeah. Now, as we're looking into this, uh, most recommender systems use this filtering process to find patterns and information by collaborating perspectives and numerous data sources and several agents. This is called as collaborative filtering to basically find out a pattern informations and numerous data sources and several agents. Do gradient descent method always converge to similar points? Does it always converge to similar points? Uh, yeah. Now, as looking into this, they do not, because in some cases they reach a local minima or a local optimum points. You would not reach the global optimum points. This is governed by the data and the starting conditions. Yeah, as looking into the next one, what is the goal of A by B testing? What is its major goal? If anyone knows the answer, please ping in the chat box. I would like to give you a minute. We'll discuss the answer in a minute. Okay. Yeah. As we're looking into this is an statistical hypothesis testing and randomized experiments with two variables A and B. The object of A and B testing is to detect any change to a web page to maximize or increase the outcome of a strategy. This is the main goal of A or B testing. Okay. As jumping to the next one, what are the drawbacks of a linear model? If anyone knows the answer, please ping in the chat box. I will be seeing those answers. We'll just discuss back in a minute. Okay. Yeah. Now, as we're looking into this, the drawbacks of this linear models are the assumption of linearity of the errors. It can't be used for count outcomes or binary outcomes. There are overfitting problems that it can't solve. Okay, these are the major drawbacks of this linear model. As jumping to the next one, what is the law of large numbers? I will be giving you a minute. We'll discuss the answer in a minute. Okay. Yeah. Now, as we're looking into this, what is the law of large numbers? Basically, this is a theorem that describes the result of performing the same experiment very frequently. This theorem forms the basics of frequency style thinking. It states that the sample mean, sample variance, and sample standard deviation converges to what they are trying to estimate. This is the law of large numbers. Okay. Now, as jumping to the next one, what are the types of biases that can occur during sampling? What are the types? Why do they occur? I would be giving you a minute. If anyone knows the answer, please ping in the chat box. We'll discuss the answer in a minute. Okay. Yeah. Now, as looking into it, what are the types of biases that can occur during the sampling? These are the three types of biases which occurs during sampling, and those are selection bias, under coverage bias, and surveyorship bias. Okay. Yeah. As coming to the last question for the day, why is R used in data visualization techniques? Mostly we prefer R for data visualizations. Why do we prefer only R for data visualization techniques? What are the reasons behind it? If anyone knows the answer, please ping in the chat box. I would like to see your answers. We'll discuss the answer in a minute. Okay. Yeah. Now, as looking into this, Why is R used in data visualization techniques? R is widely used in data visualization for the following reasons. These are the reasons for why we use R techniques in data visualization. Okay, we can create almost any type of graph using R's. R has high multiple libraries like ggplot, leaflet, lattice, etc., and so many inbuilt functions as well. It is easier to customize graphics in R as compared to Python. Okay, R is used for feature engineering and in exploring data analysis as well. So for visualization, as comparatively to Python, we have many multiple libraries in R. Okay, it is also very easy to customize the graphics in R as compared to Python. So we mostly prefer R as compared to the Python in this data visualization techniques. Yeah, this is for the day, guys. Thanks for attending the session, and let's meet in the another session. Okay, bye guys, thank you, have a great day, bye.